In section 2.6, we learn about the inverse of a matrix. We have already seen inverses when you're solving an equation. You use inverses to isolate the variable. So you use subtraction to cancel an addition because they're inverse operations. We know that if we multiply a number by its reciprocal, we end up with 1. And sometimes we say that those two are inverses of each other. So inverse just cancels out. A and A inverse would cancel each other or undo each other. So in this definition, if A and B are inverses, it would have to be true that when you multiply them in both directions, you get the identity. So just like if I multiply 2 times 1/2, I get 1. So I can say they're inverses of each other. If I multiply A times B and I get the identity matrix, then I know that A and B are inverses. So first, let's practice verifying that two matrices are inverses or determining whether they're inverses. To do that, we just have to multiply them. And if we get the identity, then we know that they're inverses. And if we don't, then we know that they're not. Not every matrix has an inverse. All right, so given these two matrices, A and B, we want to determine whether B is the inverse of A. If it is the inverse, it should be true that when I multiply A times B or B times A, I get the identity matrix. So ones along the diagonal and zeros everywhere else. Now these two matrices are both 3 by 3, so I can multiply them. So let's go ahead and find a B. So we're going to find the dot product using the rows from A and the columns from B. So to find the element 1, 1, I've got to do the dot products between this first row and this first column. So I'm multiplying 2 times -1 plus 5 times -5 plus 4 times 7. And I'm not going to have enough room here. So I'm going to go ahead and simplify that so I don't run out of room here. So 2 times -1 is -2 plus -25 plus 28. And that is just 1. Down here. To find this spot 2, 1, I've got to do the dot product between the second row and the first column. So that's going to be 1 times -1 plus 4 times -5 plus 3 times 7 plus -1 minus 20 plus 21, which is 0. Element 2, 1 is 0. All right, so to find the element 3, 1, I'm going to use the third row and the first column. I'm going to do 1 times -1, 3 times -5, -2 times 7, add them all up. -1, -3 times -5, -2 times 7, -1 plus 15 minus 14, which is 0. So spot 3, 1, I get 0. Moving on to the second column. So now I'm back at the first row, but in the second column. So I'm doing the first row dot product with the second column. That is 2 times 2 plus 5 times 8 plus 4 times -11, which is 4, plus 40 minus 44, so 0 again. All right, so now I'm going to move down to this. I'm going to move down to this spot in the second row, first column. So I'm going to dot the second row with the second row, second column. So that's going to give me 1 times 2 plus 3 times -11. So 2 plus 32 minus 33 is 1. All right, now I'll keep going. Third row, column. Third row, second column. So 1 times 2, -3 times 8, -2 times -11. So 2 minus 24 plus 22 is 0. Almost done. We just got to do this third column. So let's go back to the first row times the third column. First row dotted with the third column. So 2 times 1 and 5 times 2, 4 times negative 3 is 2 minus 12, 0. This spot is in the second row, third column. So I'm going to do the dot product with the second row from A and the third column from B. So 1 times 1, 4 times 2, 3 times negative 3. So that's 1 plus 8 minus 9 is 0. If during this process you get some numbers other than ones and zeros, or something that's not in the right spot to get the identity matrix, then you can stop. If it's clear that it's not the identity matrix, then they are not inverses and you are done. But this one, so far, it's looking like an identity matrix, so I gotta finish it out. I'm gonna do the third column and see if that gives me 1. If it gives me 1, then these two are inverses. If it gives me anything else, they are not. So third row, third column, that's 1 times 1 plus negative 3 times 2 plus negative 2 times negative 3, which is 1 minus 6 plus 6, which is 1. All right, so here I have the identity matrix with the ones along the diagonal, zeros everywhere else. So I can say, yes, B is the inverse of N. All right, if you get anything else, something that doesn't look like it could possibly be the identity, you could just say, no, they're not inverse. Okay. So now we know how to determine or verify that two matrices are inverses. Next, we got to see, how do we find the matrix, the inverse of a matrix? I have a matrix. I want to know, what is its inverse? Here is how we find it. And you may wonder, what do we need the inverse for? Well, the inverse is useful in solving a system. So let's say we create an augmented matrix from a system of equations. And so we've got some matrix times our variables, so a matrix with the variables. And then that's equal to something else. If I want to solve an equation that looks like this, where AX and B are matrices. So just like solving any other equation, I need to use an operation that is going to cancel A or make it equal to 1. And so now we know that to do that, I can multiply by the inverse and so now I'm using this notation for the inverse. If I multiply A by its inverse, then I just get the identity, which is equivalent to multiplying by 1. So that would just leave me with X. So I times X is the same as X. And if I want to multiply by the inverse on one side, I got to multiply by the inverse on the other side. But this will give me the solution. But first, let's see how we find the inverse of a matrix. And again, it is possible that the matrix does not have an inverse. Not every matrix has an inverse. Be sure to take a look at the slide. The steps to this method of finding the inverse are spelled out there. Essentially, we're going to make an augmented matrix with the given matrix and the identity, and then use our row operation to essentially swap them. So here's what I mean. I'm going to take matrix A, 1, 3, and then I'm going to make an augmented matrix, and on the right side, I want the identity. This is a 2 by 2, so I'm using a 2 by 2 identity with ones on the diagonal and zeros everywhere. I'm going to try to use my row operations to make it so that the identity is over here, and then what's over here would be the inverse of A. All right, so this one, I've already got the 1 in the 1, 1 spot. So next I need to get zeros here, and I also want this to be a 1. So that's the goal. And remember, there's lots of options of things you can do. I'm going to go straight into trying to make this a 0, and I'm going to use row 1 to achieve that. So I'm going to take row 1 and multiply by -3. So -3 times row 1, and I'm going to add it to row 2 and make that my new row 2. All right, so that's going to look like row 1 will now be -3, -9, -3, and 0. I'm going to add that to row 2. So this is row 1 after I multiply by -3. And this is just the regular old row 2. I'm going to add them together. So you see this makes this 0, which was my goal. Also makes this 0. And this will be -3, and this will be 1. So I'm going to put that in row 2, and what I have is 1, 3, 1, 0. And then I've got 0, 0, -3, 1. All right, so notice in here that I'm getting zeros on the bottom row. This would represent the equation 0 equals -3 and 0 equals 1, neither of which are true. So we've reached an inconsistency, and we would say that this has no solution, meaning that A doesn't have an inverse. There is no inverse of A. So it's not going to be possible to get 0, 1 on the left side of this matrix, but there is no inverse. So let's do another. Since that one had no inverse. So here's a new matrix. Let's see if we can find the inverse of this one. So again, we're going to set up our augmented matrix with the identity on the right side. And the goal is to move the identity to the left side. So we've already got the 1 in 1, 1 spot. I'm going to start the same way I did the last one and try to make this 3 into a 0. I'm going to use row 1, and I'm going to multiply it by -3, add it to row 2, make that my new row 2. So row 1 is going to become -3, -6, -3, and 0. Row 2 staying the same for now. Then add them together. So get 0, -1, -3, and 1. So this is my new row 2. So let's rewrite the matrix. Not changing the top row. Putting in my new row 2. All right. So now I've got that 0. I need this 2 to be a 0. So it looks like I could multiply this by 2 and then add them together. So I'm going to try that. So I am taking 2 times row 2, adding that to row 1, and making that my new row 1. So 2 times row 2 is 0, -2, -6, 2. I'm going to add that to row 1. When I add them, I get 1, 0, -5, 2. So this is my new row 1. So let's rewrite the matrix. And so the last thing is just that I need this -1 to be a positive 1. So I can multiply that row by -1 and change all the signs. That's going to give me +1, a +3, and then a -1. All right, so now I have my identity matrix on the left side. And so that means that what's on the right side is the inverse of A. So to finish this out by saying that A inverse is the matrix -5, 2, 3, and -1. You can double check your inverse. If you multiply A by A inverse, it should definitely give you the identity matrix. So let's see how we would use an inverse to solve a system. We're going to solve the system using an inverse matrix. So first I'm going to write this as a matrix equation. So I'm going to make a matrix using the coefficients from these equations. So coefficient on x1 in the first equation is 1, and the coefficient on x2 is 3. And then the second equation, coefficients are 2 and 1. And then I've got my variables, which are x1 and x2. That's what I'm looking for. And that's equal to 5 and 10. See that if I were to multiply these two matrices, this would be my dot product for that first spot, right? So multiplying will take us back here. So we don't need to do that. But just to show you that this equation makes sense. So we're trying to solve this equation for x1 and x2. And the idea here using the inverse, that if I take the inverse of this matrix and I multiply it over here, then I got to do the same thing over here, but these two will cancel out and just give me the identity. And so this will be equal to whatever this product is. But that's the process that we're about to go through. So at this point, we don't know the identity. So first step, we got to find the identity, not the identity. We don't know the inverse. So the first step is to find the inverse of this matrix. So the same way that we just did, I'm going to augment it with the identity and then try to put the identity over here. So first I'm going to do -2 times row 1, -2 times row 1, and I'm going to add that to row 2 and make that my new row 2. So if I do that, -2 times 1 is -2, adding it gives me 0. -2 times 3 is -6, adding to row 2 gives me -5. -2 times 1 is -2, adding it to 0 still is -2. And then -2 times 0 is 0, plus is 1. So there's no easy way to get this 3 and this -5 to cancel out. So it looks like I'm going to have to use a fraction. I want this to be something that when I add it to this, I get 0. What's probably easier is just going to make this a 1 first, because we can do that by dividing by -5. So let's divide row 2 by -5. So row 2 divided by -5. That's my new row 2. So I've got 1, 3, 1, 0. 0, and then I'm dividing by -5, so I get 1, and this would just be 2 over 5, leaving it as a fraction. This will be -1 over 5. Now here. So this will make it easier to make this a 0. We got to multiply row 2 by -3, and then add it 3 times row 2, -3. Add it to row 1, make that my new row 1. I'll leave a row 2. So row 1, multiplying this by -3, which still would make it a 0, and then adding to the 1, I get 1. Multiplying this by -3 makes it -3. Adding it to that 3 makes this 0, which is what I wanted. Now I got to multiply this by -3 and add it to that. So -3 times 2 over 5 would just be -6 over 5. And then -6 over 5 plus 1. That's -6 over 5 plus 5 over 5, which equals -1 over 5. All right, and so now I've got this times -3, which makes that +3 over 5. I'm adding it to 0, so it's still going to be 3 over 5. Got some fractions, but that wasn't bad. So now that I have the identity on this side is the inverse. So to solve this system, I'm going to take the inverse, multiply it by this matrix. If they are truly inverses, this should give me the identity. Oops. Right, and if I want to multiply it by something on the left side, I gotta do the same thing on the right side. So if the inverse was given to us, we feel confident about that being the inverse, then I wouldn't go through, unless I had time, the process of multiplying those. I would just say they cancel each other out. But since we found the inverse, let's do it just in case we made a mistake somewhere. So we want to multiply these two together and make sure that we get the identity. I'm going to go back and simplify there, but it's looking like that's going to come out to be identity. It is important to multiply the right side because that's where you're going to get your answer from. So I'm going to do the dot product of this row. Notice that this 5, 10, that's 2 rows and 1 column. And then my inverse is 2 rows and 2 columns. So I can't multiply them in this order. I have to multiply the inverse first, so on the left side. So I'm going to switch these. because we've got to match up that middle number in order to be able to do the dot product. So now we can multiply it. So the first row by this column, 3 over 5 times 10 is 6. So now the second row by the first column, and negative 1 over 5 times 10 is negative 2. All right, so now I'm going to go through and simplify everything. This is 5 over 5, which is 1. That's 0. 5 over 5 again, which is 1. And then over here, I've got 5 and 0. All right, so now my system is solved. And my answer is right here. X1 equals 5 and X2 equals 0. All right, so that's how we can use the inverse to solve a system. And you can see that it is a process. And this was just 2 by 2, a system of 2 equations with 2 variables. So you can imagine how long it would take to do, 3 equations, 3 variables, and more. So you can see that people were motivated to make this process using computer programs and calculators. But there's how you do it by hand.